I'm going to give a simple explanation of why, a superficial explanation of why I think the orphan string names are happening. And I didn't figure out uh, exactly why, but I found a simple solution and I found the places where it is happening. So I'm just gonna explain quickly and then I'm going to spend some time trying to figure out exactly the reason why. So I can see if the solution I found is good or if I should try to think about something else. I'm just gonna wait to see if it's streaming first. Like I always do. So I found this issue here and I just posted here as well. But this issue, they linked to a merge, which is this one. And on this one, he solved a couple of the string names, the orphan, the problem. But I didn't solve in the same way that he did here, these ones, and he didn't solve the other ones. So the problem with these ones were on the property info struct, because the property info has a string name, and when you initialize the property list helper with a static keyword, the string names are not properly cleaned. So he found this solution, and the solution that I did there was just to replace the string name with a string, and then it solves. But the issue is I'm not really sure if it's good or not, because of the way that, like, there is a difference between, I don't know how, I don't know very well how the string works, the string class, but now I know much better how the string name works, and I think it makes a lot of sense to use string names on places that you're gonna use the same string a bunch of times. So I'm not really sure if the solution that I found for this one is good, but he also didn't find the solution for the other ones. But mainly, I think it's this guy here. One of the replies here, I think it's this one. Yeah, he mentions that the reason is because of a static, and I agree with him. So I think what is happening is that every time you initialize a string name with the static keyword, the string is not clean before the string name cleanup function runs. And the string name cleanup function is the one that it cleans everything, which is the one that happens at the end when the engine is cleaning up everything. So it's basically this function here. So if you still have some string names, it's gonna give this message here, the error message, because the strings were not cleared. So I think I might like superficially explain how this works. But the places that I found was, which I believe is all of them, because I did a bunch of tests to see if the errors were gonna go away. But these are the 5 places where the problem is the remaining string names. And to solve on the places that have s name, which are 4 of them, all you have to do is just remove the s name, and then it works. And the s name is a macro that initializes a static string name. So there's 2 different ways. And this is part of the reason why I'm confused, because I don't understand very well what's the purpose of the way that they designed this. But if you want to initialize a string name that is static, one way is to pass the Boolean variable to true, which is this keyword here. And the only thing that it's going to do is just going to increment the static count here. So this is the part that I'm not really sure. I don't understand very well what's the point of this, because the thing that is responsible for choosing whether or not the string is going to be dereferenced or deleted is going to be this variable here from the data and not the static count. So as far as I understand right now, the only thing that this does is just keep track of how many strings were initialized using this static variable here, so passing through. And the sname, on top of that, uses the static keyword, is a macro that they have there, and initializes the string name with that. So if you remove that from the situations I have there now, you solve the problem. And on the other situation, as far as I understand right now, is just creating a hash map with the static keyword as well. And I believe that the reason why is happening is the same problem, because the hash map is initialized with the static. Then even though the string name gets the reference, the one that is on the hash map is not going to be the reference because it's static. And the class doesn't clean the hash map, I think. So the thing that is weird and I don't understand very well is why is that happening, since there's a bunch of other places that they also use sname to create string names, and there is no problem. So that's the thing that is very weird about it. So that's what I'm going to try to figure out now. But this is basically the macro. So this is a lambda function. It just means that it's going to return a const string name, address, or reference. And initialize the static, uses the static keyword to initialize the string name, then calls this function here. And I think this one creates a pointer from const char. So you pass the string name, which would be like this pattern here, and then you pass whatever the name. And this is going to be this marg, it's going to be passed here, and it's going to be initialized as true. And this one is going to create a pointer here. So initialize this class, and then makes the pointer of this class, which is a member variable to point to the pointer you passed when you're initializing. So like just creating a pointer inside of the class that represents the string. Because on C and C++, the string name is going to be an array. So the pointer only points to the first element of the array. And it's an array of characters. So, but this is called here. So if you do have the string, it just calls, just creates the static C string and then uses that as the constructor of the string name. And then after it does that, then there's a copy, because based on I'm going to step over now, but I think it goes 2 times. So the first time that it creates is this one, the string name, and the second time is going to be on the equal operator. So the equal just transfers the pointer as far as I understand. And then there is, it runs the destructor a couple of times, I think, or 1 time or something like that, which makes one of the instances to be the reference, but for whatever reason, the other ones are not cleaned the same way that the usually is cleaned. I think I'm gonna roughly explain, as far as I understand right now, how the string name works. But basically, the main function that is gonna run to the reference is this one. So it's dependent on this static, no, it's dependent on the ref count variable, which is a class that uses SDD atomic, which is just spend a bunch of time learning. So I might try to explain this as well. But I'm probably gonna, maybe I'll talk about it, the STD atomic as I step over or step into. Yeah, but basically, so the constructor is gonna be this one, and yeah. So roughly the way that it works is that they have this static variable, I think, which is a part of string name. So static data. So it's an array of data structs, this one, and this one keeps track of all the string names that are used. And as far as I understand right now, the way that it works is that the first time you initialize a string name with a specific pattern, they're going to create the hash to decide where to put the string name on the array that they have there. So the position of the index where the struct data is going to be placed at in the first time is going to depend on the pattern of the string. So let's say you have a string name like this. The hash is created based on this, and is based on the string class, which is this hash here. So based on this hash and this mask, you create, you get the index and initialize the data for when you're initializing for the first time, and then you initialize with the values here that depend on what you pass there. And this creates the entry for the first time on the static array of data structs. And then the next time that you initialize the string with the same pattern, so let's say you initialize a string name with the pattern like node, which was the one that was having the problem. Then if there is no string, if you're going to get the hash, so if the hash doesn't exist, the position on the index on the table doesn't exist for this pattern, then it's going to create the data struct for the first time. But if the index already exists, what it's going to do is, instead of creating another data struct, it's going to create a linked list from that point, where each additional reference to the same string name is going to use the same data, but it's going to be on the chain of the linked list that the data has. So this, as far as I understand now, optimizes more, like if, let's say you have a bunch of string names that use the same pattern, instead of allocating memory for each one, you just create a linked list of all of them. And you only allocate memory for the first one. So that's basically what's happening. And the way that it works for deleting is based on the reference count, which is basically based on std atomic, because it's based on this variable here. So each time that it is initialized, it's going to create a reference to this. So basically when it does this, so if the first time it initializes, it calls this init. And then after it does that, it calls this ref here, each time that you created an additional reference. And this ref is the thing that is going to increment the count, which is the just basically saying how many different string names you have with that pattern. So I think, is it one there? So initialize with nothing, first time, I think. So it's going to be 1, the first. And this is an atomic, or no. So this one uses atomic, I think. Yeah, this one uses the atomic to do the updates. And the way that atomic works is basically just a class that makes it easier for you to have multi-thread code, because it prevents race conditions. So race conditions happen when you have 2 different threads trying to access the same place in memory. And it's kind of complicated. I don't understand very well to explain in an easy way, but yeah. It's basically just preventing the 2 different threads, because you can have both on the compiler and on the hardware, there is something called out of order execution. It just basically means that I think most of the times the code that you write on the file is not going to be the same sequence that actually runs on the hardware. And the reason why, there's actually a picture that I was trying to, was one of the things that was very confusing, but I think I kind of clarified now. But basically, in order to optimize the pipeline, which is how many instructions you do for each clock cycle, the compiler and the hardware usually are going to put the instructions out of order, which means that they're going to, because it's kind of like saying that they assume that the programmer is going to be dumb, and it's not going to understand the hardware structure, and it's not going to write the code in the most optimal way. So for you to have optimizations, they basically create the compiler and the hardware in a way that the instructions are going to be always organized in a way that you have the maximum amount of instructions per cycle, and you take the most advantage of the hardware structure you have. But this is only a problem when you have data dependency. So let's say like you have a place that wants to write on the memory A, for example. You can't have, a lot of the times you can't reorder the execution when you have reads and writes to the same place in memory, because it's going to affect the structure of the nature of the program. So that's called data dependency. But outside of data dependency, so let's say you have A and B, different places in memory. It doesn't matter which order the stuff related to the memory B is going to be executed, because it's not going to affect the memory A. So when it comes to instructions that are like excluded, it don't depend on the order, then you can change the order in order to optimize when the instructions are going to be run in different parts of the hardware, which is called data pipeline. So like instructions always works in the same cycle, which is determined by a finite state machine. Finite state machine is just a fancy way of saying a translation between different states. So you have a predetermined translation between states, which creates a graph, which is called the finite state machine. That finite state machine is going to determine the cycle of execution of instructions, and this creates basically the data pipeline. So the data pipeline is created on top of this, because you know that every instruction is going to have cycles, which I think the beginning is going to be fetch. So you fetch the instruction, then you decode based on the instruction set architecture to see which instruction you're going to execute. Then depends on the instruction, either you're going to branch or you're going to read and write from memory. Don't remember if I think, yeah, it's this one. So this is one of the things that was kind of confusing to me, but I think I understand now. So, which is the single instruction multiple data stuff. So there's basically this difference here. So this PE are data elements, I think. And the difference here is that you can have situations, for example, on the hardware. So GPU works like that, where instead of running one instruction at a time, you are gonna, instead of changing one place of data at a time, you're gonna change a bunch of places at the same time because it's just faster. So that's called single instruction multiple data, which is the first case here of the array processor. The way that it works is that you have these PEs here, and each one is like a instruction of data. So like registers, I think. I forgot about the exact nuances, but it's basically this relationship here. So you have one instruction that runs on multiple different data at the same time. And yo, thank you for the follow. And the other situation, you have the vector processor. This is usually used on the GPU because it allows. So the thing that is kind of confusing about this and that I didn't understand at first is that the way that it is designed, because like for different instructions you have a different hardware that you're going to use to execute the instruction. And so I think that the simplest case is ALU, which is arithmetic logic unit, which is just the circuits of logic that you're going to use to be able to do addition and subtraction, for example. And depending on what kind of thing you want to do, you can have specialized hardware that is optimized for this kind of instruction, because obviously the nature of like how many transistors you have and the resistance between the different transistors is going to impact how much power you need to perform one instruction and how long the instruction is going to take. It's very complex. I'm not going to explain, even because I don't know the details very well, but I think I have a good understanding now how it works. So basically, the thing that I didn't understand is that the difference here between the array processor and the vector processor is that each block of the vector processor is like a specialized hardware structure that performs one operation. So the difference is, the reason why this is advantageous sometimes is that because you're going to spend less for each hardware place. So each one of these PEs here has to be able to perform all these 4 different operations. So it costs more for you to have the PE. But the flip side is that it allows you to do the calculation at the same time on all data you have, because it doesn't matter which operation it is, you can just do it. And on this one, you can't do all the operations at the same time, because a lot of the times there's going to be the stuff of the sequence matters. So you can add before you load, for example. So in this situation, it's still parallel. It's still executing the instruction in parallel, but it's more in a sequence way because each instruction depends on the last one. So this is the reason why. So like here, for example, when you get to this point, you're executing 4 instructions at the same time, but there are 4 different instructions. So the advantage is you can still do parallel work, but it's a specialized parallel work, and it works more in a sequential way, because you can only perform the next instruction by performing the previous one because they depend on each other. So the difference is basically that Here's going to be same operation at the same time and different operation in space. And here's different operations at the time and same operation in space. So there's a trade-off between time and space. I think a lot of situations the GPU is going to be a vector processor because they're usually, and this is usually going to happen on loops. So this is a kind of optimization that happens when you have a loop. Because when you have a loop, the compiler is going to know that the situation is going to happen a lot of times. So you can have a bunch of optimizations that take advantage, and it's both on the compiler and the hardware, because the hardware designer has to expose to the compiler, to the person that is going to create the compiler, the instruction set architecture, which is basically the interface between the software and the hardware. So, yeah. So because of this, and because you can have these optimizations where you change the order of execution of instructions, it becomes very complicated to do the multi-threading work, because the code that you're writing is not the same that you're going to see on the hardware. And for this reason, you can have situations where, let's say you're writing you're using multiple different threads, and then let's say the compiler changes the order of execution that you thought would happen. What's going to happen is that you're going to have a race condition because you're going to have two different threads trying to access the same place. Or you're going to have a situation where you're supposed to get a value. You're supposed to use a load, for example, or a store, and then goes on the wrong order. So that's the point of using the atomic. It makes everything easier because they do the code under the hood for you. So like they make it simple. It's just basically an API so you don't have to worry about the locking threads and stuff like that. And so basically, but when it comes to the thing that I didn't understand very well, and I think I understand now, is that I might be wrong about this, but as far as I understand right now, the only thing that matters is for dereferencing and for deleting string names is going to be the amount of references that you have, which is going to depend on the ref count. So every time that a string is created, it's going to call the ref, which I think is going to add. So what this is doing here basically is the count is going to be this variable, which is using std atomic, and it's checking to see if it's different than 0. And what this is going to do, so this is the thing that is kind of confusing to understand. But here, these functions come from std atomic, which is the multi-threaded stuff that I was trying to talk about. And here is going to basically load the value. And this acquire is just like normal threads where you're basically stopping other threads from accessing the same place. So like you're putting on a lock when you specify the acquire here. And you are putting the value here, and this is the function that is kind of confusing. But what is happening here is that the code, I'm not 100% sure. I think, yeah, it's probably going to be obviously the compiler is going to optimize things, I think. But the threads, so like you can have a situation where as you're trying to update the value here, another thread is going to write to that value. So you can't guarantee that the value is going to be the same. It's going to be the one that you thought it would be, which is this C here, because the C is the value that you loaded. So between the time you load here and you're going to try to change the value here, there can be another thread that changes the original value. So you're assuming that you're going to have one value and you have the other. So what this function does is basically checks to see if the value of C is the same value as this one. And if they are, then it's going to update this value with C plus 1. And if they are not, it's going to update the value of C with this value here. And the reason why it updates the value of C with this one and not the other way around is because of the multi-threaded thing. Because the value that matters the most is this value here, which is the std atomic. So this is the value that has volatility that can change between threads. So for example, if you have a situation where you loaded the value and another thread changed the value, you want the new value of C to represent this value here. So it basically, it's like a safeguard for you to not update this value on different threads. So it just stops that from happening by updating the value of C with the new value. And then the next time on the iteration, they're going to be the same, which means you're going to change this value here with C plus 1, and then it just returns C plus 1. So basically, in the simple way, it's just updating the value of this, the value that this class holds by 1 each time that you create another string name. In the beginning, it's going to be 1 because it starts at 0, obviously. And this here is just basically saying, it's creating the acquire and release at the same time. So this is what this thing is specifying here. The acquire and release is just flags to determine when you have a critical section, which is when you want to stop threads from accessing the same place. So it's like a semaphore. So the acquire, you make the semaphore red, and the release, you make the semaphore green. So this one does both at the same time, so you can read and write the same operation. So let me think. So basically, it's gonna keep track on this count variable of how many references it has, and when the destructor of the string name runs, is going to call another function that is going to decrease the count. So basically, this function here gets called. This configured variable is set up on the beginning of the engine on the main setup function, as far as I remember. And the data is the struct for each string name, which is a pointer. In the beginning, it's going to create the memory on the actual table, and then after that, it's going to create additional references to the same place. It's just going to create the linked list that I talked about. So it's going to link different data. I think the first time it creates the memory, and then it creates links inside of the memory. I don't remember really well, but I think that it doesn't allocate memory after the first time, but maybe it does. Yeah, because I know for sure that it is a linked list, and it keeps track, but. So the main function that is going to run is this one, to reference, and then this call here is going to decrease the count. So you can imagine that each time the constructor runs, increases the std atomic by 1, and then when the destructor runs, it decreases the atomic, and it does basically the same or similar operation. So this is just going to be the same as this is kind of tricky as well, but it's like the same as decreasing the value by -1. And the reason why it's kind of tricky is because it's different than doing like this. Because on this situation here, you're going to run multiple operations on a single sequence. And this one, in order for the atomic to work, you have to do all the operations at the same time, let's say. So if you do this, then it doesn't work with the atomic, which means you can have the race conditions, and then it can fuck up everything. So basically, the fetch sub here is basically doing this on an atomic value. And what it's doing is just decreasing the value by 1. As far as I understand right now, maybe it's wrong, but I think that is correct. So, if this is going to return, I think, false when it is not equal to 0. So it means that when you don't have references anymore, this is going to be 0. So it's going to return 0, which means that the string the data, the actual memory has to be deleted, and then that's when it's going to run this stuff here. So it checks to see on the linked list here. I think at this part I don't understand very well. So maybe it does create a memory for each one. It's just on the main hash there. That it keeps. I have to see on the constructor again, but it's basically just removing the pointer along the linked list here. So it makes the previous equal to the next, and then just removes, because it's going to delete the one that connects them, obviously, and then just deletes the data. So if it is not 0, then it just makes the pointer equal to 0. So it's basically decreasing or removing the pointer after you decrease the count. And I think that's the way that he works for deleting the string names. But the thing that I don't understand very well is like what is the logic behind the connection between this and the static because as far as I understand, there's nothing here that is, except this warning message here, is based on the static count. There's nothing that is directly related to using the static to initialize the string name. So I think that might be the issue. It's probably based on the way that they design, which I don't understand very well. Yeah, but here, so here I think it doesn't create, it doesn't create a new memory place there. So it is kind of confusing, the structure there, because like, why does it track the place of the data on the linked list if it's only gonna delete the memory once? That's the thing that is kind of confusing. Yeah, but basically what is happening here, you're just gonna point the pointer of the current string name to that place on the table, and if this exists, then it means that it's not the first time that the pattern is created for the string name. It means that there's already a string name with that pattern, and then it just traverses the linked list to see at what place is gonna put the new one. I think it might. The thing about the linked list might be because there's true, but it's kind of weird anyway. Because if it already exists, it's gonna return here. So this would be the data structure based on the index. So if already exists, it's gonna make the previous point to the current data points or current data. I think that this is the first time it initializes. So the first time is just gonna make the previous link to the current one, and then it makes the current equals the new data that created. So I guess if you have different initializations, maybe it doesn't do this here. So this would be the first time there that creates, so this data previous would be, oh, I think I understand. So I think what is happening here, the reason why it's checking, is making this check, is because you can have a situation where the first string name that creates the memory is not the first one on the linked list, I think. Like you can have a situation where you create a string name with a pattern, let's say a node, and then later on you create another one. But then the destructor of the first one runs, which means that you're not going to have the first pointer, but you don't want to delete the memory because you still have other ones that depend on the same place. So I think for that reason, you have to check to see if it has a previous. Yeah, because the other ones probably don't have the previous value. So I think the only string name that has the previous is gonna be. But actually, not really sure if that makes sense. And maybe it does make sense actually. So it's a singlet linked list. So all of them only have next. The first one has the previous. I think that's probably the case actually. Because only initialize the previous here. So I think the only one that has the previous value is going to be the first, which is going to be the current. So the one that initializes the memory is the one that has the previous. I think that's how it works. So here it checks to see if it has the previous because it's checking to see if it's the first if it is the string name that initialize the data. And if it is, then it just it moves the pointer to the next one. So this would be the current data because the previous and the data are the same based on the initialization there. And then it's just moving to the next. Yeah, so it's basically removing the first and then making the next one should be the first, I think. I think that's what's happening. Data next, next previous, equals data previous. This is probably so you can do the same stuff here, but I think it's kind of weird though because like even the ones that are not gonna have the previous are gonna have the next. So I'm not really sure what this is about. Yeah, previous. But I guess it doesn't matter that much because it's only going to do the additional pointer assignment here. Then next time. So it's deleting the current one. But it's kind of it is confusing because if it only creates the memory one time and then deletes here, then it wouldn't make sense because like the other ones that still exist are gonna be messed up. So I'm not really sure if I understand what's going on. Maybe because of the maybe because maybe when you make it equal there, it's gonna create another data. But I'm pretty sure it doesn't. Based on the previous times that I run this, I think it just points to the new one because it is a pointer, not an equal operator. The constructor just reassigns the pointer of the data of the variable to the new one. So this is kind of confusing. But like assume that on the first time that it runs this, if it is the first time that it runs this and this is true, then it means that it is the first node, so it's the one that created the data. It's making the next. Sure. Next. Just bridging the gap. And then if the data has next, it makes the previous. So let's assume that this is not true. I guess that this would run then. And it is kind of confusing. Because all of them are gonna have the next. So this is the thing that is kind of weird. But I guess it's gonna be a null pointer if it's not the first one. But either way, it's kind of weird because it's gonna delete here anyway. I don't think that this is the problem that's is happening there because you would just crash, I think, if you was or if you deleted this while the other stuff still dependent on it, then it would create the ending pointers and it would just crash. The thing is, the problem is something else. But I do think it's weird to do these assignments here if we're gonna delete the data. So I think there's something happening with the actual data on the table. So maybe when you use memnew and when you create this one, then it does create an additional uh, place, let's say, on the table. So you're creating you're allocating memory two times. I'm not really sure. But one time you create on the memory pool. Every time you use the memnew macro, you're just using the memory pool based on the operator here. As far as I understand, this makes it so that instead of new allocating the memory where it would usually do, it allocates the memory on the memory pool that they created. And it's based on another, I think it's based on the overloaded new operator that they have here, which runs the other class that they have, which is the memory alloc. So this makes it so that they use safe numeric as well for the allocation. So I think it's these ones. It's like global variables that work as a memory pool. So all the data is compacted. And I went back and I watched the video. There's a very good video about, I think the tech lead or the whatever the name is for Godot. She talks about the memory pool or the memory stuff on Godot. But from what I remembered, I thought he talked more about it. But the main thing that I took from it is that they do memory on a growth only way because it seems to be, I think it is faster. So every time you allocate memory in Godot, it's only going to grow. So when you remove the memory, it's not going to deallocate. And usually the default way is to deallocate. But I think the allocation makes it a lot slower. So basically this video here, it talks about this. It's a very good video. Basically here. So if you add the data, it only grows, and then if you remove, it stays the same size. So this is the reason why. Here, I'm not 100% sure, but if you press F12 on VS Code, it goes through one definition from one third-party library that they have. But when you step over, it goes through the usual like standard library thing. So I'm not really sure if it's using this one from this third-party library. I think it makes more sense to be this one because otherwise, what would be the point of doing the memory pool there? But I'm not really sure. Maybe the point is just the new operator there. I'm gonna put breakpoints, I think. So I'm gonna put the breakpoint where it assigns the value here. Just see if it's gonna create a copy, an extra one, or not. Maybe we should put breakpoint on the reference there as well. On ref. Yeah, I'm gonna put another breakpoint here to see if I can understand what's going on. I'm gonna ask ChatGPT as well to see if there's anything to remember the explanation that I think I not only I got the explanation from ChatGPT and from other sources as well, but it has been a long time about the new operator and the empty string there. I'm gonna ask ChatGPT. So I think what is happening there with the Orphan string names is probably something to do with what happens after, because in a lot of situations, like I said, they are using the S name as well. So each time you're using S name, you're creating a static string name. But the thing, based on the step over that I did last time, do think for sure that it's gonna run the destructor each time for the string name. But obviously, since it's static, it's gonna continue. So like it does a bunch of copies and then it runs the destructor for one, I think. But then the one that was initialized with static still remains. But then the weird thing is that why doesn't it destroy the other instances? So I think the only explanation that makes sense for me right now is that for some reason when you have the situations that are giving the problem there, which are the situations here, it uses the string name on other data structures that are like inside of the functionality of these ones. And then because of that, then those data structures are not cleaned in the correct way or something like that. So it might be very annoying to figure out what is going on. Also, I think it's because they override the new operator. So because they're using this one of this, then the string name is gonna be one of the arguments here, I think. This is probably what's happening. So this one is gonna be the actual class. I'm gonna put the breakpoints, I think, just to see if I. The problem with the breakpoints is that you can't. It doesn't go over the macros, so yeah. It puts here. I guess it doesn't. I don't need the breakpoints. Just stop in here. I'll put 0 one more time to see what happens. I have to put some of the other ones as well. So maybe it's either obviously the description or the size. I think obviously it has to be the description because the size is gonna be probably the class token there. Obviously, otherwise you wouldn't be able to know how much memory to allocate. So I think the binds are the size, and this is gonna be the string name is gonna be this stuff here. So let me just I'm gonna stop intro. Nothing about this layer. So this I before I started streaming, I just got to the point there on the first part that the issue happens. This is a no string. But the descriptor seems to be the empty thing, I think. It's not used for anything, I think. It just indicates that it's gonna use. Well, I think it's just so you can use the overloader operator. I think if you don't put the string name, obviously one thing that I can test, just remove and then see what happens. Not really sure if we would crash the engine, whereas I can try that. But I think what is happening is that you put the empty string name to so that the compiler understands that you're supposed to use this function instead of the standard one. So this is the part that is kind of weird. So when I press F11 here, it goes to the Microsoft kernel stuff. This I think usually it doesn't show the file just because of the setup on the VS Code debugger, and didn't spend time trying to figure out how to make it so that the file shows up. Maybe it's not even possible because it might be compiled and you don't have access unless you reverse engineer. But yeah, it's basically going to the main definition. So I think he's using the main one. I guess I can ask ChatGPT as well to see what it says. I think it's kind of fucked because of the previous stuff that I saw there. I'm going with my user balance. It's not directly used. Yeah, I think he's just using the standard one. And the only difference is that he's using that safe stuff there, which is an atomic class built based on atomic variables. So it allocates based on the size of the class, I think. And then it's going to increment the atomic variable, which is the count, probably the count of how many classes it exists. And I think probably uses this to because they have two main global objects, one global classes. One is a class that is going to keep track of all the objects, which is the actual memory that is allocated for each object, because everything on Godot is going to be an object, everything that is used on the engine. And the other one is a class that keeps track of the types. So all the types that are used on the engine is the class DB that keeps track of that. So I think there's a lot of counts used on the object DB, but I'm not really sure. Object DB is the one that keeps track of the objects and the objects lots. Object underscores lots is going to be the global variable that keeps track of all the objects, the memory. So it's using the fetch adds. The thing that I don't understand very well about this is why it's increasing by 1 here. Oh, I think I understand. So what happens, but I'm not 100% sure. I'm gonna ask ChatGPT, but I think the one that I know for sure is when you use just exchange and not the variation of the exchange. So if you do just value dot exchange, what is gonna happen is that it's going to. No, I'm not really sure actually. So maybe I should ask. But there is something. Yeah, I think that it changes the value. Uh, so usually when you create exchange, you're passing a value. Yeah, but I'm not really sure. Like I think he changes the value and returns the old one. Yeah, that's pretty sure that's what happens. So if you had value dot exchange, then you would change the value anyway. So and you would change the value and return the previous one. So let's say value was 5, and then you called exchange, and then pass 7. The value would become 7, but then the function would return 5. That's how it works. But here, I don't understand. So I'm gonna ask there to see because fetch adds, as far as I understand, should add by 1 here already. So it's kind of weird that does. Yeah, I think that that's the reason why, because when you return, you're returning the previous one. So it is what is said there. So I guess all the operations are the same. So these automatically changes the value. So when you increase by one here, you're not changing the value. You're just changing the value that is going to be returned by the function. So this operation changes this value by one, but it returns the old value. So let's say value was 0 in the beginning, is going to, this stuff is going to return 0, and then because you want to return the accurate value, you have to increase by 1. But this increase by 1 here doesn't, so the first situation, this would be 0, then it changes to 1, because it added 1 to 0, but it doesn't change to 2, because I think the value that it returns is not the same as the value. So I think that makes sense. I wanted to spend some time as well looking into the source code here, but I think that I'm not 100% sure, but I remember from Python that I think in some situations you can't really see the source code just by stepping over because it's going to be like a black box. But I don't understand very well why. But I do remember on Python sometimes I try to step over to see how the Python implementation works. But I think when you're running like the program, you're not going to have access to the way that the compiler is going to work. Or yeah, you don't have, for whatever reason, don't have full access when you're stepping over to the actual source code that created the things. I think it's the same thing here. So there's some functions that you're probably not going to be able to access just by stepping over, but I'm not 100% sure that's the case or not. Volatile is, as far as I understand as well, is just a keyword that is very similar to the atomic stuff. It's just signaling to the compiler that the value you're using might change or might depend on different threads and stuff like that. So it's just a weaker form of SD atomic, but it lets the compiler know that you probably shouldn't reorder the execution of the program when it comes to that variable because it might depend on different threads or stuff like that. But here, I think it's probably all the source code here. Just returning the previous value, which is the result. And then it changed the... Yeah, I should change here. This is probably the function that runs. Atomic address storage. So I think you can't really see what is going on. Because there's probably something else going on rather than the stuff that I saw there. Yeah, maybe it's because it's a macro, so it doesn't show. Yeah, I think it's probably because it's a macro, but I'm pretty sure that even like some functions for whatever reason or not, you can't really see by stepping over. I think probably the reason why, what would make the most sense to me is that the reason why you can't see some of the functions is that what's happening is that the operational system is executing a process when you are going over with the debugger, and the process is going to be the executable that is the language, which is basically the compiler. Yeah, so, like it's the full thing, because obviously like when you create the compiler, you're creating tokens, then you creating code that parses a string and transforms into the intermediate representation, which is an abstract version of that code that is going to be able to be translatable into different architectures, hardware architectures. Then the interface between the hardware and the software is going to be the instruction set architecture. Each different hardware is going to have its own instruction set architecture. And then the compiler you're using is going to determine whether or not, if they created the code, whether or not you're going to be able to compile to different architectures. So the compiler is just a program that is going to contain the parsing of strings into this into the final assembly code, which is going to be the intermediate representation is going to be the abstract version, which is the version of the language that is common across all the different platforms. And then after that, you're going to have the code generation parts. It's going to take the intermediate representation, which is just an abstraction of the language, and it's going to convert into actual assembly, because the assembly is a mapping to the instruction set architecture, which is determined by the hardware designer. So the person that creates the hardware is going to determine what kind of bits are going to be related to what kind of structures, what kind of instructions, because it codes the hardware in that way using combinational logic. I realized that as well, that it doesn't matter if you say combinatorial or combinational, it's basically the same, but just Boolean algebra. So that's how you code. The first function that is created is actually on the hardware, because you can have circuits that you're going to be able to map inputs to outputs. And that's basically the first function. And then with those circuits, you are able to determine what bits are going to do what based on the control logic of the hardware as well. The control logic and the memory based on the von Neumann model, which is the one that is the most used. And then the other model is the data. So I think that's why you can't really see everything, because you're running the compiler, which is an executable. So you're not going to have extra information that is going to allow the debugger to be able to see the symbols and the functions of the code that is actually running. This is beyond the process that the debugger has access to. I think that's what's happening. Yeah, so if you put so obviously the problem is that it generates a black box. So I guess the only way to be able to see would be to either use an open source compiler and then spend a bunch of time trying to figure out, or reverse engineer one, but it's probably illegal, or yeah, not really sure. So I'm not going to spend too much time on this. Yeah, so you just incremented the counts there. It's kind of weird because so maybe uses on the memory. Yeah, it's probably like some garbage collection, garbage collection stuff. It doesn't have anything here. It's kind of weird. So I'm not really sure why they use this. It's just the three places, and it's kind of weird. I guess I'm gonna ask again. The only explanation might be because the only thing that makes sense would be the resources here. And something to keep track of the resources, but it looks like it's like a different variable, so whatever. I'm not gonna go over this stuff. It's probably to display debug message, debug error messages, so it's not because the allocation probably already happened with malloc. So I think he's just calling malloc and allocating on the memory. Yeah, but it's kind of weird. So I think that I understood it the wrong way. Like I didn't understand very well the first time. So maybe it isn't that different from just using malloc. It just adds extra things there if you want on the whenever you're gonna debug. But I'm not really sure. I'm not 100% sure. So this is after the macro runs there. That is the first time it's gonna create the first string name after it runs the macro. So it's gonna create the string there. I think it already created the static string. Yeah. So created the static string, which creates the pointer, and then it's gonna use this to create the other one. This one I have to study as well, the mutex, because I don't understand very well how it works yet. I'm just storing the value. So this one, as far as I understand, this memory order here is uses whenever you want to synchronize the multi-threaded code. So because of the reordering, you have situations where you want to keep the sequence the same, so that you don't have problems with reordering, just to synchronize the code. I'm gonna go faster. So this is the first time that it's creating, I think. It has to be because it's running the data. So this is one of the things that I was thinking about. This might be one of the differences, but then it's kind of weird because I assume that there would be more places. So like the reason why it might be just 5 places that the error message is happening is because even though it uses the S name a bunch of times, it only uses for the first time on 5 different places. So the problem is on the first one because the other ones just decrease the reference, but the first one is not deleted for whatever reason. But I'm not really sure. Obviously, so if I knew, then it would be solved already. So I think that the way I'm gonna try to solve this or to figure out, because the solution, like I said before, I already know, like the simplest solution that I can think. So on the one that doesn't use as name, I think that if I clean the thing there, hash map, then it's probably gonna solve. It's using the static string name. And on the other ones, all you have to do is just remove that name, and then it's gonna work. But then the problem is, I think it's not very good because the reason why they probably did it this way is because whenever you want, whenever you have a place where you're gonna use the same string name a bunch of times, you don't want to create a new one, I think, each time. So it makes more sense to to make it static. So I think just by removing the S name there is probably not gonna be very good. One thing that I was thinking about is creating or changing the string name so I have something that I can put these instances of when you create with S name. I can put them on some data structure, and then I can put on the destructor before the cleanup happens. I can destroy them or create another function on the string name that just deletes them or something like that. I'm gonna skip this. This one, yeah. So I pressed F11 there to step into, and it didn't do anything. So I assume that it only creates the memory once. Now it's kind of weird. I think I'm gonna have to go over the second place that it happens, that the error is happening, because now I'm not really sure if I'm still on the same one. Because now it looks like it's still, from what I remember in the previous times, I think that it wasn't the first one, but maybe it is actually. I don't remember very well. I think that this is probably on another place. Maybe not. Because last time that I did this, I didn't put the breakpoints on the free, and I just step over, I think. So I don't remember. Or this is like it's not supposed to be going over this. I think it's going on another place. Yeah, I'm just gonna press F5 and I'm gonna try to get to the next spots. But yeah, the reason why I put here is I want to just see. So this is one it doesn't have. I guess this situation I understand. Is this one that I want to see? I don't understand this part though. Well, here is just making the place on the table to point to the next one because I'm gonna remove the current. What I don't understand is the memory. Like if it's gonna delete the first one, the one that allocated the memory, isn't it going to create dangling pointers for the other ones? That's the thing that it's kind of weird. But I'm not gonna be able to understand this just by stepping over here. That's the problem. Like I need to get a situation. Maybe I think I'm gonna do this another time. But one thing that I could do is just put the breakpoint there and then write down the situation where this happens, like get one of the situations where it happens, and then try to track the like what happens with the other references that have the same pattern. So I can get a situation, for example, where a string name with the pattern node is created, and then I can look into the other instances where it's going to be destroyed, and then like see what happens with the value. Let me just press. So this was one of the situations, I think. I'm pretty sure it is. I think right now. Is this one? So this is the first time. So I create the thing for the first time here. You just create the pointer. This is gonna be the node pattern thing. It's the end because it's the first one, but I'm pretty sure it's gonna be node, this string. Then you use this as the constructor of the other one. To create the hash. So in this case already has the string there. It already has the data on the table. So the pattern is gonna be nodes. Then it increments the reference by 1 based on this compare exchange. Then it, because you initialize, when you use the thing there, the macro is gonna pass this as true, so it's gonna also increment this count here. I think the only place that this is used is on the error message there, but I don't think it impacts the destructor and constructor of the string name. Unless I'm missing something, obviously, but based on what I've seen there, I think it doesn't do anything. And this is the time that is kind of confusing. So it runs the first time because it has the constructor there, so initializes, and on this constructor is running this constructor again because this is when it's gonna make it's gonna actually make the static one, as far as I understand. So the first time that it runs there is based on the static C string, and the second time that it runs this is because of the macro, and the macro doesn't show when you're stepping into. So yeah, it's running the destructor again because of the quality here, as far as I understand. So the first time it runs here, it runs this constructor here, then it returns this string name, and then the second time is the one that is the equal there, which is this equal here, which is, as far as I understand right now, the time that is going to create the actual static string name. And then it just points the data pointer from the static one to the other one. So it might be something related to this. I'm not really sure. But the reason why is having a problem there. So the data from this one is the string name that gets created from the static C string at first, and then just making the pointer of this one to point to the other one. It might be because of this, the problem there. And now it's gonna destroy the first one. So the first one gets destroyed, but I think it doesn't run another destructor because it's creating the static. So it doesn't run the destructor for the string that is created with the static keyword, but it runs the destructor for the first one after the macro finishes, I think. and it's just making the pointer null and decreasing the count there. So it's kind of weird the order because it doesn't show it doesn't snap into the macro. It just skips the macro code on the debugger. So this is gonna be the static one. I think I'm gonna stop here because I'm probably not gonna be able to figure it out now. And the way that I think I'm probably gonna try to figure this out is by doing some experiments. So I think it's gonna probably take time because I'm gonna run I want to run on situations where the S name is used to create string names and you don't have the problem, and on the situations where I have the problem, so I can compare the difference between both. Just see if I can figure out why on these situations it creates it doesn't clean the string name, and on the other it does. Others it does. Probably gonna run experiments as well, just see what happens. As here, it doesn't seem that there is anything weird. Like it uses other string names here, so this one is not the one that initialized there. Another one that initialized with S name. And then it runs the destructor here for some of them, and it uses the node string name on the theme stuff here, but I think it's probably not this. I think it's most likely the issue is something related to the first time that you initialize the string. That's the only thing that makes sense to me now. It should be something related to that, or either that or uses the relationship between the string name and the other data structures. But the thing is, on the theme here, like this is gonna be used on the map, which is part of the theme. But I already tried to clean the map, I think, or maybe actually it might be because of this, because I didn't try to clean the theme on the window. I tried to clean the hash map on the theme class, and on the theme DB, I think, and another theme class that the editor uses. So, but I don't remember if it might be because of this stuff here, because this is not cleaned. So maybe I could try to do this. So on the destructor, just call clear. It doesn't look like it calls clear on this. Huh. Oh, it's calling here. Yeah, but this is something else, I think. It might be because of this actually. So, because it doesn't run this function on the destructor of this class, it only runs on the other thing there. Because the other thing is that these errors happen only when you run the editor version. On the other one, it doesn't. So it's something related to the editor functionality. So I'm not really sure because obviously this the window class, but it might be related to the way that the editor manages the thing. So it's connected. I was running initializes and then it updates. Yeah, so every time that it cleans up, it creates them again, I think. So it might be because it's not cleaning the map there properly. Yeah, I think that this might be the issue. The thing is, it could be multiple different issues as well. So it could be one issue in this situation, and on the other situations another. But the main reason why is because of the static keyword. I'm pretty sure that that's the case. So the issue is that based on the way that they did the string name class, whenever you initialize a string name using the static, you're gonna have problems, I think. But the thing is weird is that it does clean. So maybe this is probably the better way to go about it. Is like trying to figure out at one moment the other instances where you create as a static string name using the S name macro. That at one moment does it clean up the memory or dereferences the string name on the other situations. This is the reason why I think it might be because even though it uses S name many times, the ones that, but I think that's probably not the case because it's only one pattern as well. The ones that use S name is all nodes, I think. Yeah, so all the different problems use the same pattern of string name, which is the node. So if it was because of the first initialization, then there would be other warning messages for other patterns of string names. So it must be something else. It must be related to the way that they use later. So the way that this class is used, the S name, I think. I'm gonna stop here, and I'm gonna try to solve this off stream. Probably next time. Not really sure if I'm gonna talk about this. Maybe, yeah. Maybe I'll talk about it in the beginning to just say how I solved this. But I'm just gonna continue to go over the steps that I have there. And yeah, so not sure when I'm gonna come back, but yeah, see you next time.